with the event. Hey, welcome everyone. This is part 8 of a 10-part webinar series on the 8 mathematical practices, which are part of our proposed 2022 math standards in the state of Minnesota. Today, we're going to be looking at Math Practice 7. We only have 3 more webinars to go. This one in 2 weeks, and then one in 5 weeks from today. I'm super excited to be here today. I'm Sara van Werf. I'm the State Academic Standards Specialist for Math. And as I said, this is part 8 of a 10-part series, but it's Math Practice 7. I have shared a ton of resources with you already. In the chat, you will find links for these. I'll also give you a QR code if you want. But in there are professional learning protocols, how you can use the recordings of these webinars with people in your thing. If you scroll down, there are tons of links and resources on the second and third page of this document. Just tons of things that will be useful to you. As always, I always want to center our students here, our K-12 students in Minnesota, in the work that we do, because our goal is to improve the conditions for their learning, because we're preparing them for life after high school. And if you take a look at the top 10 skills needed in 2027, according to those who forecast what our students are going to need to do, you'll notice that have a rise of digital technology, but our real life students are going to have analytical thinking and problem solving and critical thinking and analysis and complex problem solving, all things related to today's math practice. A lot of times people will ask in this era of AI, what can't computers just do all the math? And they can do a lot of math. But if you look at that bottom paragraph, computers can only plug and chug, but humans can think. And look at that second sentence. They can notice patterns and structure. And like that sentence right there is Math Practice 7 that we're going to be looking at today. Humans can detect nuances. They can learn from experience. They can use previous problems to solve new ones. And today we're going to look at our standards, the proposed 22 standards, and the 2 dimensions that overlie all the benchmarks in our standards. And so we're working this school year, on Dimension 1. We're at Math Practice 7. Next year, I'll be doing a webinar series on Dimension 2. And if you scroll to the bottom of our proposed standards, you'll see a long paragraph on Math Practice 7. I'm just going to, for right now, you can go back and read my slides and read the whole thing, or open up the standards. Just read the first sentence, which says, mathematically proficient students look closely to discern a pattern or structure. If our students are proficient, they're looking closely for a pattern. I want to remind you, as I do in all of these sessions, that the math practices are not something that students magically arrive to our schools having. It is something we develop with greater and greater sophistication from kindergarten through 12th grade. We, the educators at all levels, it includes leaders in the building, are seeking to develop in our students. So we create the experiences that allow them to develop these skills. I've also showed this graphic in all the sessions I've done. It's a graphic by Grace and Amy, but what's new today is we haven't had this since Math Practice 2, is all of the math practices are supporting Math Practice 1, making sense and persevering in solving problems. If your students give up, it's because they haven't developed the other math practices. But 3 of the math practices are the drivers, the things that students need to be able to do to persevere. And so we looked at Math Practice 2 in the fall. Today and in 2 weeks, we're going to look at the last 2 drivers, looking at structure and looking for repetition and how that drives the work. As always, I'll center my students. I particularly want to center my students, which are on the right in this picture. Those are the students from the last classroom I was teaching at. I was teaching high school Algebra 2 at South High School in Minneapolis. And the goal is, how do we create the conditions? And I've said that this is my favorite math practice. And that's because this is the one that I think I got right a lot of the times in my classroom. And I'm going to tell you that story. In fact, you can see them engaging in this practice. I created the conditions with that little thing that you can see the students holding in their hands. And we'll talk about that throughout this. So in that picture, my students were looking for and making use of structure. So what does that mean? I always like to start with Robert Kaplinsky's adaptations of the practices. Robert says that math practice 7 is simplifying problems by using their structure. Another way of saying that is our mathematically proficient students use patterns and structures. That's that first sentence from the paragraph in our standards to strategically transform complicated problems into one or more simpler problems. And so the goal of math practice 7 is for students to use patterns and structure and then transform complicated problems into simpler ones. So let me give you some examples of what that looks like. In the early grades, students might look at a problem like 99 plus 46, and they might be looking for patterns and structures and using things from before to help them transform things. And they might think in their head, ooh, 99, it's really close to 100. And if I just take one number away from 46 and give it to 99, I can make 100. And they transform that equation into something that's more simple and easier for them to do. And they would do 100 plus 45. Here's another example. A student might think when they're learning about areas of quadrilaterals, they might think, I don't know the formula for a parallelogram. I don't remember it. I only know how to do the ones for rectangles, base times height. Well, we can then transform shapes as we develop this practice. Students will transform shapes, and then they create simpler problems, things that are known to them, things from prior work. A lot of this practice has to do with how I transform my classroom to simultaneously teach past material and also future material. Students in high school with me in Algebra 2 might look at this problem and be, ugh, some of you in this call might be like, I don't know how to find out what X is. But as we start to transform that 81 and look at what are the factors of 81s, we might notice and how we start that 81 is 4 factors of 3, 3 times 3 times 3 times 3 times 3. And if we can make both the left and right side of that equation have a common base, we can start to look at the exponents and say, ooh, that X must be 2, 4 times 2 is 8. And it becomes a whole lot simpler. One of the big questions about math practice 7, a lot of people nationwide where they've had these math practices longer than us don't really like math practice 7 because I think it's too similar to math practice 8. So in this session, in the 1 and 2 weeks, I'm going to try and help you look at the difference between those two math practices. They both start with the phrase look for. We're doing math practice 7 where we're looking for structure. Math practice 8 is looking for reasoning and how we create those structures. So we're born mathematicians. These are my nephews. They spent 2 hours with my dad as my dad was teaching them a new game when they were just little. They're older now. I love this picture because it shows the natural curiosity and wonder and just like stick-to-itiveness around mathematics and logic that we have from birth. And then what happens in school to take that away? And when we get them in 5th grade, in middle school and high school, they just don't want to do things. Well, research says around 2nd grade, students start having an identity in math that says, I can't do it. And about 2/3 of those students have that identity. And a third feel pretty good about themselves with math. By the way, those statistics stay through adult, and nothing that happens in classrooms after 2nd grade tends to change that attitude. So I think this math practice is the secret to changing our students who arrive to us engaged and curious, full of wonder, versus the students from the Ferris Bueller movie sitting there and listening to their professor who are just disengaged and compliant in the classroom. So there's a lot of research on that. If you've never seen the math research on why students aren't engaged, there's lots of reasons. I'm just going to highlight one of the reasons, and it's their belief about what math is, because that's really connected to this practice. So if you have heard me talk before, you have heard the next few minutes of my presentation. I start every school year by asking my students what math is. First day of school, their homework is, what is math? Define math. Tell me everything that you know about math. If you were thinking, you might, I want you to think just for a minute, predict what my students would say. I'm going to show you in a minute what my Algebra 2 students said. I have a slide from my real life classroom. But a lot of what they say is based on how we learn math. This is why most adults don't like math. This is how I, Sara Van Werf, learn math. When I was in geometry class, they said, take notes on this, write down the exterior angle sums of polygons. We're learning that today. Draw this picture. We're going to look at the outside exterior angles, and the exterior angles of any polygon add up to 360 degrees. And I'd memorize it. I'd ace the test on it, and then I'd forget it a couple months later. Well, what that results in is what my students said about math and what most adults said. The next day, second day of school, I say, what do you know about math? And I chart everything that they say. And even if they say it's hard, I don't like it, it's boring, I put that up on the thing. And if you look at what they say about math, most of those things are not really, they're things that happen in a math classroom, but they're not the definition of math. So on the second day of school every year, I put up a poster in my room and I give my student the definition of math. Check out the word that's highlighted there. I've been doing this for 25 years. This is not a new thing, maybe even 30 years. Math is a study of patterns. Math is a study of structure. That's math practice 7. When we can convince students that this is what they do, their lives change. And so then I talk to them about what mathematicians do. And I say, every day in this classroom, we're going to do these 3 things. It's my job as your teacher to create the conditions so that, 1, you can, as a mathematician, practice noticing patterns. Math practice 7 right there. The second thing that they do is they describe the patterns. And so whatever they notice, they're describing. And then the third part is they generalize. So I'll give you an example of what that looks like. So rather than learning math like this, in my classroom, if I'm going to teach the same topic, I'm going to put this in front of my students and treat them like mathematicians. And I'm going to ask, hey, students, what do you notice? And students will take a look at this picture, this GIF that's changing, and they'll start talking about the colors that they see. They'll talk about the outside angles. I'll add in some academic language, the exterior angles, the outside angles, and they'll say it all comes into a circle. And then we'll talk about what do you know about circles? And soon enough, students will say that sentence that you see at the bottom of the other picture. Oh, the outside angles, the exterior angles of any size polygon, they always add up to 360 degrees. They are owning the learning. They're practicing being mathematicians. Is because a tweak that I made as the adult in the system to give them a chance to notice and describe what was going on. It is so easy to do this nowadays. I steal a lot of things from TikTok that you can just download from TikTok and put in your classroom. This is one on the sum of the angles in a triangle. I could never make this. I still would have students like cut out a triangle and rip off the corners and put them together. But this can show that all triangles, despite the shape, the 3 angles always add up to 180. So math is a study of patterns, and I need to create the conditions so my students can notice, describe, and generalize. So this is my goal as a teacher. This is how I plan my lessons. In my classroom, we study patterns and structure, and every day I will make sure my students are noticing, describing, and generalizing. And so that means I have to ask the question, what do you notice? Where's the structure? I have to create something for them to see the structure. Maybe I'm connecting it to something they've seen before. So I said that math practice 7 and math practice 8 sometimes get confused. Well, if you take a look at what we're looking for in math practice 7, we're looking for structure, which is patterns. That is part of my definition of math, what mathematicians do, what I've been doing in my classroom for 25, 30 years. I'm creating the conditions so that in math practice 8, which we'll talk about in 2 weeks, they can generalize and express regularity. So when we think about the definition of math, this is a poster I have in my classroom. Oh, I didn't put this in the folder, but if someone reminds me at the end, I'll upload this resource, or if someone knows my email me and I'll put it in the folder, all my stuff that I do at the beginning of the school, my first homework and all that stuff, and this definition and something you can make a poster if you wanted. But really, mathematicians notice patterns. In the math practices, we call that structure. They generalize patterns, which is expressing regularity and repeated reasoning. That's the difference between math practice 7 and 8. Describe goes with both parts of those 2 things as well. So as many of you know, Minnesota artist and author Ben Orlin, mathematician, created some graphics to go along with our 7 or 8 practices. You'll get them in the last session in this webinar series, all of them, and a whole bunch of resources I put together with them. But here's what he said about Math Practice 7. He made a structure for students to look at, and he said in math, structure is another word for patterns. What patterns do you see in this image? So if you're like, Sarah, what is like, whatever. I'm going to show you what this would play out in my classroom on day 3, because I've used things like this the first month of school every year, and it's transformed my students' engagement in classroom better than anything I've ever done. So in my classroom, I would take what Ben said, and I would ask my students, hey, what do you notice? Mathematicians notice things. Tell me everything you notice. And to get real specific, I have them stand up like you saw in that photo earlier. And I say, you got to list at least 10 things that you notice, and it can be things like color, picture, number, objects, and whatever. And then I bring the class together and say, what do you notice? And I chart it all down. And they say, I see blue, and I write it down. I say, what else? I see turquoise. What else? I see a face. What else? I see big eyes. What else? I see lots of circles. What else? I see a square. I see 16 circles. What else? What else? What else? And I would keep going. By the way, you might have noticed that the first few things weren't that mathematical. You better write them down, because they have to get out of their head the things they see first, and that's often color and shape and those kind of things. And they eventually, if you keep asking, the number one question in my room is what else, what else, what else? After I ask, what do you notice? And I get a lot of things shown at me. So how does that support students in building this? Well, when they see and say there's a square, I also annotate that into the picture. And we talk about what we know about that square, that it's a 4x4 square. Some students, I didn't keep the what else going, will say, well, I see 1, that's one color, and then 3 this color, 5, and then 7. And some other student will yell out, oh, those are odd numbers. And so when we put those things together, we have a square of 4x4, we can find the area of that, and that's 4 squared. Or if we looked at the odd numbers that people saw, we could sum those up and add up 1 plus 3 plus 5 plus 7. And it turns out that both of those give us a total of 16 circles. We have 2 equivalent expressions based on 2 different patterns that students saw. In Math Practice 8 that we'll do in 2 weeks, we can start to extend that and look for regularity in repeated reasoning. I'm going to tell you right now, if I was a elementary teacher, upper elementary, middle school, or high school teacher, students are going to have great guesses about what they think the other expression for 5 squared is going to be. They're going to predict that there's going to be some more odd numbers coming. And all of that leads to them doing things. You might recognize what Ben drew. It's part of something that's pretty famous. It's from Von Wynn. I've linked to it. It's a common instructional routine called visual patterns. I use 10 of these, 1 a day for about 10 days in the first month of school. And I just asked, what do you notice? And we start annotating and putting things there. So I took Ben's image and turned it into a visual pattern. It's not on Fawn's site yet. I'll have to talk to Fawn about adding that. But Fawn has 500 of these. So if you're like, I don't have things to do, you should go there. Because eventually students will apply this to all the shapes. And what happens is they start with 1 and they look for the patterns in the structure. And then when they do more of these, they start to do MP8 that we'll talk about later on and say sentences, generalizations like the sum of the n odd integers starting at 1 equals n squared. So again, Fawn has a whole site. There's 500 of them. I have it linked in the document that someone will link in the thing. So, or in the chat. So this is one of my favorite ones to start with on day 3 in my classroom. Start simple. I often just start with one of those 3 pictures, often the biggest one, and say how many, rather than what do you notice to start with, and then they start to apply things that they notice. And kids will see that in different ways, but then again, the question I ask the most is what else, what else, what else, what else do you see? And then I help annotate that. All right, math practice is also about students stepping back from what they're working on, taking a pause, and trying to shift their perspectives. And so if we want students to be good at Math Practice 7, it requires our students to manipulate the math to find a way to solve it. and to connect noticings to prior knowledge. So here's a math fact that I blank on all the time. If I blank on this, I can step back and I can pause and I can shift my focus. And I can apply this to previous learning and say, ooh, I know how to take numbers apart. I know how to decompose them. And so I could take that 8 apart and say, well, I know 8 is 5 plus 3, and I like 5s, and I can use the distributive property, even if they don't know those words, decompose and distributive. And I know 7 sets of 5 is 35, and 7 sets of 3 is 21, and I can add that in my head. And I have other ways of thinking about things. I know I'm doing math practice 7 when I can do these 3 things. By the way, this is from Amy, who's written a book on routines for reasoning and has written about the math practices and routines you can use in your classroom. And she says, I know I'm doing MP7 when I can describe chunks of parts of things within the problem, when I can change the form of the object, and when I can connect it to math I know previously. Woo, that's that accelerated learning that's happening there. So if you take a look at this problem, you might freak out. I don't know how to solve for X, but if you can step back, pause, and shift your thinking, and just look at how I can change the structure, I might be like, ugh, I don't like fractions. I prefer decimals. So you might turn this into a decimal and turn that 7 halves into 3.5. Oh, there's another 3.5. You also might be like, but that other one is opposite. But I remember that I'm allowed with addition to use the commutative property to switch the order of things. So you might switch the order of things. Well, now you have 5 sets of x plus 3.5 and 3 sets of x plus 3.5, and you're supposed to subtract them, and that leaves you with 2, and then you can continue on doing things. But students who can see structure can make problems much more simple. A lot of this is in Amy's books, Routines for Reasonings. She has a routine called Contemplate, then Calculate, where you show students quickly a problem, have them contemplate it. You just show it to them for 3 seconds, have them talk to somebody about things they might have seen. I'm going to show you guys again for 3 seconds without talking. In the chat, if you saw something in that you just noticed something about the structure, that's why we take it away, because we're having them not calculate things right away. We just want them to contemplate and think about the structure that they're seeing. A lot of students will start to say, I've done this in my classroom, this routine, they'll say, ooh, there's a lot of multiples of 9 in there. And they'll start to look for ways of grouping these things and chunking these things to help them make sense of what the whole thing is. By the way, there's not one way to chunk these items. You could look at opposite items and realize that they're all sum up to either positive 90 or negative 90, and those things cancel out, and you're left with just 45 in the middle. Another instructional routine that really supports Math Practice 7 is choral counting. This book by Megan Franke and others is amazing. It has a couple of routines in it. Choral counting is when you have intentionally made some way of skip counting. It can be with fractions, decimals, or all kinds of things. In this case, it's counting by 4s. You can start with numbers that are higher up and do a bunch of things. But then when you have choral counted, choral meaning everybody in the class counts at the same time, not just one student, you then ask them, what do you notice? And students start to say the things that they notice, and they're looking for the structure that exists in numbers. And they start to make predictions about what other things would be. They look at place value and they see the structure of place value, and you give them this experience on an ongoing basis. It helps them see things. I'm running out of time, so I don't have time to play this whole thing. But if you go to my PowerPoint, you can see a little video on choral counting and play around with learning more about that. I also linked in my resources to several people that talk about choral counting, but everybody goes back to Berkeley. Like one of our keynotes coming to our conference, our symposium, is Graham Fletcher. I heard him do a webinar this weekend, and he was using choral counting, and he recommended Berkeley Everett's choral counting resources. If you're a secondary teacher and you say your students don't know fractions, embed choral counting as a routine using fractions, and ask your students to look for structure and compare and contrast fractions and decimals and do things. So SMP7, MP7 in the classroom, give students a chance, give them the time. That's probably the time in that first bullet point is things pause, be silent, give them private think time to make observations about the behavior of math, the structure of math, the patterns, the characteristics, how it's organized, and then have them use those observations to solve problems. And then you, the teacher, identify which observations they made initially that were really helpful in the problem solving process. Help them become more efficient. In my PowerPoint, I included lots of resources on things people ask about themselves when they're doing MP7. For example, they might ask themselves, how is this problem similar to something that I have solved before? I've also included what structural thinking looks like and non-structural thinking looks like. If you want to build structural thinking, what you see on the left is the classic algorithm for subtracting numbers, but students who have structural thinking, who can see the structure, will say things like you see on the right. I included several examples of this, of very normal things that you would do in your classroom, like all the way up into like pre-calculus examples. And so go and check this out. I also have a lot of this linked in all the links that I shared with you. There are some pitfalls if you create problem solvers or pattern noticers, is they'll start applying patterns to things that they shouldn't be applying patterns to. And that's why we're the teacher in the room, to help them think about that. We also don't want students' structural approach to be called unique or advanced or different, because then we're putting our bias of what is efficient on their natural way of thinking. So be really careful with that. I'm going to end really quickly with just 3 things that MP7 is about. It's about being lazy in the best possible way. MP7 is about using what you know and what you notice. And then MP7 is about pausing, stepping back from the problem and looking for helpful things. So I don't want to add up the numbers 1 through 100, kind of like the classic story of Carl Friedrich Gauss, a famous mathematician. And so I'm going to go look for a faster way of doing this. If you've never done this, check out the TikTok.
If I ask you to add up all of the numbers from 1 to, if I ask you,
explains what's going on and explains where this formula came from. But really, students have no problem, if you've ever done this problem, seeing that there are 50 sets, half of the data sets, that all sum up to 101. If you've never seen that problem, it's a great task at all grade levels, especially upper elementary through high school, for students to engage in before you give away the punchline. MP7 is about knowing, using what you know and what you notice. It's about using stuff from your previous learning. So if you're in middle school and you're teaching students to distribute things that have X's in them, put that side by side with things they would have used with integers in elementary school when they were doing the distributed property, and ask this question. Rather than telling them how to distribute, say, hey, what's the same and what's different? And give them things that have representations, that value rigor, that are conceptual and build procedural fluency. MP7 is about stepping back and noticing. And so again, I have another different GIF about the sum of the angles in a triangle. Don't think that you can't go find things that allow students to view things differently. So I have a whole bunch of information on there. But I just want to end by saying, where is patterns in the Minnesota standards? Well, in our current standards, the word patterns are all over. There's a whole progression of patterns in our current standards. So you should be doing this now, because this is what math is. Math is the study of patterns. All the way through high school, you will see benchmark after benchmark talking about patterns. In our new standards, there's 7 anchor standards. And the 7th one is all about patterns and relationships. Terry Weiberg's going to do a whole training on it this summer. And at every grade level, there are benchmarks all the way through high school that do that. So last thing, I'm going to encourage you to steal my learning target for the first month of school. This is what I do. I do math practice 7. Hey, students, let's engage in noticing patterns, describing change, and writing general rules. Math practice 8. I use that every day for the whole month of school, because I'm trying to create mathematicians and deconstruct what they believe math is. That's my goal going through that. By the way, I have a whole bunch of resources in there connected to early learning, and they talk about what pre-K students and K students need to know about this and what that looks like. And so go check out all my resources. The link is also in the chat. If you go to the second page, you will see it for all the sessions. This is what it currently looks like, and there's a whole bunch of links. And the things that I highly recommend checking out is that toolkit where there's a whole bunch of rubrics I didn't even show you today. There's PLC protocols. In green is that rubric. So the next webinar is going to be the last Math Practice 8. I've kind of touched on it today, but I'll have more to say about that. And yeah, thank you for coming.